right, I'm glad to have you here to start on our GIS Basics workbook. So the premise behind this workbook is that rather than having like PowerPoints and different slides and different files to download, basically we just have a workbook and I run the lectures through the workbook. So it's got some information and you can fill notes in and you can look at things. And then in tandem, as we move through this, we'll also be opening up the software. We'll be getting into ArcGIS Pro. I'll be showing you things. You'll be opening it up on your own. You'll be trying things. So it's kind of like we work together to start to get into the software. So our section one, we're going to start out today. And really with this, we're a little bit less into the software and we're a little bit more into kind of the basis behind what we're doing. So this is a great section to start as you're just beginning to download the software to your machine if you're taking the course online. And it's a good way to just kind of get a foundation under us before we start to click on our mouse and press buttons and build crazy maps. All right. So we're going to look at the landscape around us and kind of a big picture look at map making, what it involves, how we're going to do it, and really how it's going to fit into our careers. Because we're here kind of in a, get our boots on the ground, get us out there making maps quickly. So at the beginning of each section, I go through some objectives that we should be able to perform. And in this case, we want to be able to do the following when we're done with section one of this workbook. We're going to describe the components of a GIS, explain where ArcGIS Pro fits within the suite of different GIS software. We're going to describe how GIS is used in the environmental sciences fields, because that's going to be our focus, kind of natural resources, water science, agriculture. We're going to apply ethical reasoning to situations involving the use of geospatial data. And we're going to develop some strategies that are going to help us, not just in class, but as we move forward into the workplace to make sure that we're doing our best work, being our best selves. So let's take a look here. You should have this fillable PDF workbook with you. So when you open it up in Adobe Reader or Adobe Acrobat, so you need to make sure you open up the workbook in Adobe Reader or Adobe Acrobat, you're going to have fillable boxes that'll help you with note taking. So I've set those up. I'll also show you how to make sketches in this notebook so that if you're taking your notes online, you're able to kind of put those all together. We use notes. You can use notes throughout the class, including on quizzes and exams. So it's nice to have some well-developed notes, and you come out of the class with some tools to help you. So if you don't see fillable boxes here, it's probably because you don't have the workbook opened in Adobe Reader or Adobe Acrobat. So Adobe Reader is free software. You should be able to have that available to you to work with this fillable. If you are an old-fashioned kind of person, that's all right. You can print this out and you can write on it, and then you don't need to worry about it being fillable. So we're going to start out with some key questions. So every section of the workbook will have a main topic, objectives, and then we're going to have some key questions that we look at. So our first key question is, what is a map? So when we're looking at a map, we're looking at a scaled representation of the world around us. And so the idea is it's not exactly everything in the world around us, but it's going to be scaled down, and it's going to just represent pieces of the world. So we're going to be relying on symbols when we're working with a map. And if we think about it, and we were to look at something like, well, let's take, for example, we're going to be using this as we move forward in a couple sections. If it's Spokane County, if we wanted to make a map of Spokane County, what would we put on it? Well, let's see here. I'd want the county boundary, right? So we'd know, okay, this is Spokane County. What else? What would you think about it? What would you put on a map of Spokane County? So take a minute, think about it. What else could you put on? You could put rivers, you could put cities, you could put roads. What about like mountains, like Mount Spokane? What about state parks? Would you put that on a map of Spokane County? What about schools? we might want schools, all the schools in Spokane County. What about fire stations? Would we want those? What about neighborhoods? You know, there's different neighborhoods in town. What about city parks? What about wildlife areas? What about lakes? What about docks and fishing access? So think about Spokane County. If we had a map and it was even like 8.5 by 11 sized, and we put all of those things on a map, on that map, would we be able to read anything? No, it's going to be insanely cluttered. I mean, you could even add hospitals and fire hydrants and culverts and bridges. And pretty soon the map is not usable. So what we do when we're making a map, it's called cartographic generalization. And I'm capitalizing generalization because that's the important piece, okay? And so cartographic generalization, what we're doing in that is we're deciding what is most important, then emphasize that, and then drop or fade or minimize everything else. Okay. So cartographic generalization. We don't put everything on a map. It's, first of all, it's scaled down, so it's shrunk down by a scale. And then we decide what's most important for the viewer on this particular map. And that bumps up to the top and that's shown and everything else is minimized. We'll absolutely show a lot of examples of this as we get into design and symbols. But if we were to think again about that map of Spokane County, let's say we wanted to focus on parks and recreation. So we could do county parks, we could do city parks, maybe we would also do water bodies, and maybe mountains and maybe highways, right? If you're looking at the whole of Spokane County, you might want some feelings for how you're going to get around. So the highways, but the highways wouldn't be the brightest or the boldest. What would be the brightest and boldest on that map would be the parks and the park boundaries. And then you might want to see, like I said, the waterways, because a lot of times parks are associated with those, and you might want to see a way to get to the parks. So you choose what goes on the map, and you choose its hierarchy. So that's what generalization, cartographic generalization, is based on, that we can't show everything. Similarly, if we're looking at something like at the scale of the whole United States, right, we might have letters that go across a range and say Rocky Mountains, right? So it might say Rocky Mountains if we're looking at all of North America, but it's not going to go down and it's not going to separately label the Selkirks and the Bitterroots and the Cabinet Mountains, right, which are all ranges within the Rocky Mountains. So we're just kind of looking at hierarchy there. So part of cartographic generalization is applying an appropriate hierarchy. So important elements are visually dominant. All right. Okay. So what is a map? So it's going to be a scaled representation that you have applied cartographic generalization to. So when you look at a map, it's going to be a scaled representation of the earth around you with cartographic generalization applied so that the items that are most important in the hierarchy show the most dominantly, and other items are either left off or are less prominent. So we've got a few broad categories of maps. A physical map is a map that looks at the geographic features of the world around you. So a physical map is going to be like features on the ground that you can see. So it could be things like, we'll say it includes features on the ground that you can see. Includes features on the ground that you can see. So examples here are going to be things like rivers, mountains, cities. You can see cities. They don't look like dots, do they? That's a symbol for a city, but you can actually see a cluster of houses and buildings, and that's going to be a city. So rivers, mountains, cities, let's see, Caves could be on them. You can see caves. The things that you can see on the ground are going to be physical features. So things that have weight, have a visual appeal. Even like things like swamps, wetlands, forests, those are absolutely physical features. So if it's something you can see, it could be on a physical map. Here's an example of a physical map, and this is showing features of the United States. And it's got political features, the cities, and cities are things that are tangible as well, and those are just represented by the dots there. But you can see the mountain ranges, and you can see here, like I said before, here you've got the Rocky Mountains, but do you see the Selkirks up here in Idaho? No. Or do you see the Cabinet Range over here in Montana? No, you don't. Do you see the Goat Rocks Wilderness down here? No, you don't. That's because it's generalized, and it covers a large area, so you're just taking the most prominent pieces there. So that's going to be a physical map. A physical map has features that you can see, that you can touch, that are tangible, that are physical. Okay, so there we go. Physical map. So that's a broad category, and we're talking very broad categories. If we were just going to put maps into two categories. Another type of map is a thematic map, and a thematic map visualizes less tangible pieces of information with a spatial component. All right, so less tangible pieces of information. Well, a thematic map, so it might be a map of something like this. This is the percent of people who experience love on a daily basis. Now, is that something you can see? No, you don't look on the ground and see, oh, it's like a road, which a road would be on a physical map, right? But a thematic map could have something like you did a survey and you found out, hey, here's the percent of people that feel loved on a daily basis. You can see that we are rich in the love belt over here in the Western Hemisphere. Yay for us in North America, South America are doing pretty good. I'm glad that I don't live in Eastern Europe. Parts of Central Africa, folks aren't feeling as loved on a daily basis. Anyway, a thematic map, that could be something like census data. Data could be on that. So demographics. So just kind of examples there. Census data or demographics could be on a thematic map. And other pieces of information could be things like exports, or it could even be information like percent canopy cover. So you're not showing where the forest is, you're showing percent canopy cover. I'll put that on as an example. Percent cover of different things. So you're not saying, hey, there's a forest here. Instead, you're saying, hey, Washington State gets to be light green because it has, 68% canopy cover or something like that. Census data, percent cover, income information, that kind of stuff. Okay, which could also be included in demographics. Or you could have something like the number of wars fought in that country since 1800. Thematic maps have less tangible pieces of information, but still have that spatial component. So you're looking at them by a boundary, like a county or a city, or even we have like water pollution. So we can show waters that are in Spokane County that are on the state 303D list. That's a list of water bodies that are polluted. And so you could show those in red, each of the water bodies. Now the water bodies themselves are tangible physical map features, but if you show which ones are polluted in a given color, now you're getting into a thematic map, because that's not something that's necessarily visible. It's just a piece of information you got from sampling, that kind of thing. So thematic maps. And important to note that, yes, these are two broad categories, but obviously sometimes they overlap. Like you're going to have physical features on a thematic map. A lot of times you'll have political boundaries, and political boundaries, well, they're nothing you can see on the ground, are they? So they're not really physical, but we include them on a lot of maps because they help us orient, because we're used to these kind of geographic political boundaries like county boundaries, state boundaries. So there is a little bit of, a little bit of overlap here, but there's some pieces that are kind of clear. If you're dealing with a bunch of census data, yeah, you're dealing with a thematic map. And we'll talk about this as we create maps through the class. So we've got our physical maps, boop, and we got our thematic maps. All right. So let's take the next few minutes to talk about how a map is made. So the data collection piece here, this is an important one in part. Let's make sure these are, I don't know why I'm centered here. We'll see how typing works. The data collection piece is important because this is often where technicians are involved. And so that could be working with a GPS. Maybe I'll just have to type it straight. So you could be working with a GPS. You could be working with, I'm going to pause this for a second and see if I can get the font a little bit smaller. All right, well, maybe not, but you can hear me anyways, even if you can't see all of the typing. So, like I said, how is a map made? Well, we've got our boots on the ground. So those are folks who may be collecting information, like you might be going out and doing a culvert survey. And so you drive a road. Every time you get to a culvert, you stop. You enter it into a GPS location detecting device. Often those are just going to be handheld, kind of pad-based interfaces. You'd be working with like I said, a GPS. You might be georeferencing. We were going to talk about what this is in a few weeks, but basically it's taking a paper map or a map that's not digitized yet and creating digital features from that. You might be looking at, I know we've had some students do this kind of work as technicians, looking at paper forms, inputting locations, or you might be actually sketching on a map to create features. Okay, so I know you can't see all of that, but you could hear me. So the idea is data collection is often that's the piece that you might start out with from a career perspective, okay? So generally, when we start out, especially if we've gotten a technical hands-on degree, folks are going to be excited. They're going to be, all right, you know how to do stuff. Let's get you out there. And you might be out in the field with a GPS collecting information about the real world around you. You might be, let's hope it's a rainy day because I know we all like to be outside, but you might be in front of a computer screen using your mouse to sketch out features that you see on an aerial photo, or you might be taking an old map and taking the features from this old paper map and putting them into a digital map. So that's kind of the process of data collection. And it can also include features like data collection also includes if you're going out and doing vegetation surveys, if you're going out and doing rare species surveys. I think about how many times, my time in the field when, you're out there and you're collecting spatially based information. And so back in my day, we'd have like a GPS and we'd use that to record our location when we found something, or we would record plot center for where we were searching for something. So technicians really are, they are generally the workforce, the army on the ground that's collecting that spatial data. And so we'll talk about vocabulary kind of we get on here, but when I talk about spatial data, that's any piece of information that has a location associated with it. So spatial data, any piece of information that has a location associated with it. And if you're collecting information and you include a location, you're getting stuff that's ready for a map. Then we've got processing. And so the processing, oftentimes it's technicians that do this and analysts. And basically you're making the data readable. So technicians and analysts, and you're making the data usable. Okay, so you're making the data usable when you process it. So that can be things like taking LiDAR or information you get from a drone, LiDAR/drone, and processing it in a way that makes it usable by the software. It can also include taking paper data to digital. So if you've got data forms and you've included a latitude and longitude on them and you've written it down, you may have to get that into a database so it's ready to put on a map. but it's that processing piece. It may be going through a database. So some of you have probably worked in Access. Some of you have worked in Access or Excel. So you've worked in Access or Excel, and you're working in that, and you're just going through rows and rows of data and pulling out duplicates, making sure that everything is quality checked. That's the processing, and processing is not like sexy, exciting, but it's something that needs to get done. And, you know, on a rainy day, it's not so bad to do. So that's the processing piece. So you've collected the data, then you have to make sure that it's ready to feed into the program. And then we get to visualize it on the map. So here's where we're using our GIS, which we'll talk about more in a minute. But we're getting in there with the GIS, and we're placing features on the map. Placing features, we are editing and creating features. We are choosing symbols. We are working with cartographic generalization. Cartographic generalization. And that's what we're deciding what's most important and what to fade or not to show at all. Decide what to show, what to fade or not to show. So visualization, we're getting everything on the map, and we're getting the symbols worked out. So that's the third step. And then the last step here is going to be layout, and that's where we're putting the map on a sheet of paper, virtually. Okay, so we're taking the map, we're placing it there, and we're giving it, we might be giving it, so we're going to be adding, we're going to call these our essential elements, which we will get into later. Essential elements. So that's going to be things like the north arrow, the sources, etc. You're also going to adding informative text. You might be adding photographs. So let's say you did a rare plant survey and you've put a bunch of points on a map that show where you found like water howellia. That's a local endangered plant. And then you wanted to put some information about like the flowering times for water howellia, and maybe you wanted to put some pictures in your layout. So when you create your layout, you've already got the things placed on a map. You put the map on a sheet of paper. It's a virtual sheet of paper. Put the map on that sheet of paper, right? And then you add things like photos, explanatory text, your north arrow, your sources. That's the layout. You know, you decide what size you want it to be. Do you want it to be a little 8.5 by 11 notebook size, or do you want to cover the whole wall? That's the layout process, and students usually really kind of enjoy the layout process. It's kind of a design thing, and a good layout can really grab your reader. It is an important part of the map. So how is a map made? It's absolutely going to start with you. It's going to have you in the middle, and in this class, you're going to be doing these parts. On the job, it kind of depends what kind of a organization you work for. Sometimes in big organizations, you'll be working more on these first two steps. It just depends how they're structured. In small organizations and some agencies, you'll be making the whole thing. Some, the layout's already going to be made for you, and you just pop some things into it. So you'll find out. In this class, we're going to give you the skills to do what you need to do up through there. So that's how a map is made. So who collects the data? Yeah, technicians. Mostly, unless you have like biologists that are really, that are bored, or sometimes biologists will be out there, but a lot of times really it's the technicians. From a financial standpoint and from a preparation standpoint, technicians are ready to be on the ground. So like our hydrologic technicians are going to be out there collecting stream flow data. Our wildlife technicians are going to be out there looking at wildlife habitat, maybe occasionally capturing, small mammals or something, right? So technicians, that's you when you're done with the degree, right? Who collects the data, and maybe if I know we've got folks in here from our agriculture, urban forestry programs, and absolutely you could be out there on the job collecting information on tree diseases, on locations where you've done pruning, on places where you've got power lines coming through urban street trees. So we'll be out there on the ground. It's the folks who are outdoors that are collecting the data. So that's good to know. And then we'll talk what's used to process and visualize the data and create a layout. That's a GIS. And in order to keep this video from getting too long, we're going to pause there. And in part 2, we're going to talk about what a GIS is. So what is used to process and visualize the data and create a layout? It's a GIS. What is that? Tune in next time and we will discuss that.